Conversion efficiency of solar panel by cooling system. My paper ID is 5163. Author name is SS Kale, SS Gaude, BR Berasta. Let's go with the content. Content is introduction, literature survey, experimental setup, result and discussion, conclusion and references. In introduction, the electrical efficiency of photovoltaic cell is adversely affected by a significant increase of cell operating temperature during absorption of solar radiation. The efficiency of photovoltaic module decreases with heating, and also the photovoltaic cell will exhibit long-term degradation if temperature exceeds a certain limit. PV cell absorbs up to 80% of incident solar radiation. However, only small part of absorbed incident energy is converted into electricity, depending on the conversion efficiency of PV cell technology. For crystalline silicon, a PV cell, a drop in electrical power output of about 0.2 to 0.5% was reported for every 1 degree Celsius rise in PV module temperatures. In this work, active water cooling is utilized to reduce the operating temperature of PV module. However, when a PV module was operated under active water cooling condition, the temperature dropped significantly, leading to increase in efficiency of solar cell to between 12% to 14%. Here, the experimental setup arrangement is shown. There are 4 experimental setup arrangement you are observing. First is a conventional photovoltaic system. Second is a conventional photovoltaic system with reflector. Third is a conventional photovoltaic system with reflector and with cooling system. And last is conventional photovoltaic system without reflector and with cooling system. In this is the general system or conventional system where you don't find any kind of reflector or any kind of cooling system. So we have taken a reading for a conventional photovoltaic system. In the second experimentation, what we have done, we have added a reflector over here so that the solar rays which are falling on reflector, it reflects and falls into the PV module. Here we are having an arrangement to change the angle of this reflector also. We have tested and we have found out that the optimum reflector angle also. In third system, at optimum reflector angle, we have provided a cooling system and we have used cooling media as a water here. And third, with cooling system but without reflector, what is the reading that we have tested. So there are 4 arrangement, and we have compared the 4 arrangement with each other. In the result and discussion, we have plotted a first graph of photovoltaic efficiency for reflector at different orientation of photovoltaic system with reflector. Here what we have done is, in order to find out optimum reflector angle, we have plotted this particular graph. On the x-axis we are having reflector angle, whereas on the y-axis we are having photovoltaic power. In this case, we have found out that at the reflector angle near about 120 degree, we found that a maximum photovoltaic power we have achieved, that is near about 90. In the second graph of time versus efficiency, we have plotted here the efficiency of photovoltaic system with and without reflector is plotted. So here we are having 2 curves with reflector and without reflector. You can see that this is without reflector, blue color line is without reflector, whereas the brown color line is with reflector. From the graph, it's very clear that with reflector, the efficiency of PV module goes on increases. And this efficiency is plotted over the time. We have found out that the highest efficiency we got around 2 p.m. and it's around 14%, whereas without reflector it was around 12% or 11%. So we can say that by using reflector we have got an increase in efficiency near about 2%. In the next graph, which we have plotted a time versus efficiency, the efficiency of photovoltaic system with reflector and with cooling and without cooling. So reflector is there, but there are 2 curves with cooling and without cooling. So you can see here, without cooling is the blue color line, whereas with cooling is brown color line. So when we use a cooling system, the efficiency got improved. But the interesting fact what we have observed that after 3 p.m. the efficiency drastically reduced in both cases, cooling and without cooling. Here also we can see that the improvement in the efficiency because of cooling system, and a highest efficiency we got once again near about 2 p.m. In the next graph, power of photovoltaic system with reflector, with cooling and without cooling is plotted. So here we have shown efficiency, whereas here we have shown power. Here we can see that the power, highest power, once again we have got near about 2, and again we can see that from 3 the power drops suddenly. Okay. Then next graph of electrical efficiency and temperature. So here we can clearly see that as the temperature of PV module goes on increases, the electrical efficiency goes on dropping, and when the temperature goes above 50 degrees Celsius, the efficiency drops suddenly. Here we have plotted a two curve, without cooling and with cooling. So with cooling graph is a blue line and without cooling is a brown line. Here you can see that once again with cooling we got a higher efficiency, and but when the temperature goes above 50 degrees Celsius, the efficiency drops suddenly. So we have to take care that, or we have to make an arrangement such a way that your PV panel temperature should not go above 50 degrees Celsius. So if it is going above 50 degrees Celsius, then the electrical efficiency drops suddenly. So we have to use a cooling system to keep a temperature of PV panel less than 50 degrees Celsius. Here we have plotted a graph of voltage and current, and we have checked that what voltage we get with cooling and without cooling. So this is what without cooling system, and this is what with cooling. You can see that with cooling we observed the higher voltage. Here without cooling it's below 20, but with cooling it has gone up to 21 or 22. In case of current also, time versus current graph, in case of this current, we don't find too much change with cooling and without cooling, but again after 3 we seen that the drastic reduction in the current. So there is a voltage variation and current variation for with cooling and without cooling system. The conclusion of the research work is that the electrical power of photovoltaic system fitted with reflector compared with conventional photovoltaic system is improved by 5.53%, and electrical efficiency is improved by 7.02% by fitting reflectors. The electrical power of water-cooled module with reflector compared with simple cooled module is improved by 7%, and electrical efficiency is improved by 12.01%. The experimentation shows that the temperature range of 34 degrees Celsius to 50 degrees Celsius, the efficiency is in the range of 10% to 12%. After 50 degrees Celsius, the efficiency drops drastically. So we have to take care that the PV panel temperature should not go above 50.